Everybody, a round of applause for Jeff Martin.
Hey, y'all. Am I sounding okay? All right, so yeah, my talk's called Testing a Large GraphQL API with Aplomb. In case you were thinking this, it's not a library. It's better than a library. It's confidence, especially when in a demanding situation, such as a production web application. Oh. Huh. Can't do that, huh? Ah, there we go. Yeah, that's me. I'm Jeff, senior platform engineer, Teachers Pay Teachers. I have an email address. I have a GitHub. I wrote this little library called Plug Instrumenter. Check it out. So yeah, this conference is about Elixir in production. So I'm going to just talk about, I'm going to be like breadth first kind of talk, just high level things, freewheeling approach. Basically just like try to share some of the like wisdom I've gathered maintaining this thing over the last 2 years. Probably going to get lost in the woods a little bit, but hopefully that's okay. I mean, it's still pretty early, so we're still fresh. So yeah, I'm going to gloss over a lot of details during this talk, but you know, I'll be here if you want any more information about things that I'm touching on. What is TPT? We're an online marketplace for teachers to sell course materials, typically selling them to each other. That's it. Is it large? Yeah, I think it's pretty large. It's over 10 years old. We have about 10 services serving production traffic, and like hundreds of containers. I don't even know how many. They're written in 4 languages, including Elixir. We've got a legacy stack that we need to support. We've got 5 SQL databases. The main database has 400 tables or so. It's federated. It's a leader, like 5 or 6 replicas. And you know, generally, we're serving about 3,000 requests a second during the business hours. So you know, it's not like super duper high scale. There's a great talk about that if you're into that sort of thing. In ElixirConf last year called Cajoling the Bird. It's about how like Grindr uses Elixir at high scale. It's really cool if you're into like beam optimization, kind of Phoenix presence, high scalability, nitty gritty stuff. If you're into that like me, it's a great talk. Anyway, so yeah, not quite at that level, but like 3,000 RPS, and like during a sale it gets like 2 or 3 times that. So nothing to sneeze at. Is our API large, though? It's pretty large, about 1,000 files, like 1,000-ish modules, 200,000 lines of code, about 3,300 tests as of like when I set up this talk. We've had about 60 contributors to our code base over the last 2 years. Yeah, we max out around 25 deploys a day. So not a huge amount, but not a small amount either. Right now we have about 6 product teams, got more domains. We use GraphQL. I'm just adding that on there just because it's like a little bit of extra to think about on top of HTTP or REST. You know, GraphQL and HTTP like don't need to go together at all. So you need to think about how they interact sometimes. Like GraphQL error doesn't transparently just map to like the HTTP code that you want. And yeah, we've got technical debt for sure. We're a marketplace application. Things move quickly sometimes. We got sales, we got promotions, we're running experiments all the time, sometimes like several market shifts, and we need to be able to adapt quickly. Sometimes to keep up, we are willing to incur some tech debt for some length of time. Also, just to point out, we're single node Elixir container deployment. We don't do any multi-node communication stuff. Pretty much just a traditional web app, really, that happens to be written in Elixir. When we do inter-service communication, we all decided that we're just going to use HTTP for that. And yeah, we use Kubernetes. have opinions, whatever. Here's a photograph of me talking about our architecture. I feel that way sometimes. And watch out, it could turn into a picture of me during this talk. So yeah, let's just get into it, talk about how we test at TPT, and hopefully start getting towards talking about testing with Aplomb. Yeah, these are the three main types of tests that we write just on the day-to-day at our company. What we call them, just unit tests, GraphQL tests, which are more classically integration tests, and we have external tests, which are more classically system tests. There's a lot of great talks about writing property tests and unit tests. I'm going to try not to repeat things that are in those talks, but I can point you in the direction of some after this if you want. This is just a graph of the rate of new tests over the last 3 months. It's roughly 50 a week. We've got, like I said, 3,300 tests right now, not counting CI setup time stuff. The unit tests and integration tests run together. That completes in about 4 minutes. System tests complete in about a minute. So yeah, you can see here the most churn is with the unit tests at the top there, and then we see the GraphQL tests are a lot more stable, and then system tests, we hardly ever mess around with those. They're pretty much static. Here's an example of a unit test, pretty much what you expect. We call a function. It's just a little self-contained function, and yeah, pretty much what you expect when you think of a classical unit test. But we also consider something like this. We just call it a unit test. And it's not really classical anymore. This test is like putting data in a database, asserting its model functions, read the data from the database, return it in an expected shape. Our goal with unit tests is not so much to test every subsystem in isolation, but rather just to have the flexibility to test our implementations in ways that we find meaningful for us. And maybe that's one subsystem, maybe it's a collection. So technically a lot of our unit tests are integration tests. Here's an example of one of our GraphQL tests. It's testing our wish list feature that we have on our site. We put some user product data in the database. We issue a GraphQL mutation. We query our products field to get back the data we just wrote. And that context argument you see on the right of the two GraphQL queries there, that refers to the absent context or the GraphQL specific operation context. Something else to note, you probably have heard of Phoenix has a thing called concise. This is not that. Basically, if you don't know what that is, concise basically lets you have an API where you can basically make HTTP requests in your tests, but the way that it's implemented kind of removes the TCP socket part, so it runs quickly. And those are really handy too, and we have plenty of those. But it's just nice to have the flexibility to override that for certain kinds of tests, or not, and just always kind of still be close to the client-facing edge of the application. These are really important tests for us. They give us a lot of confidence in the sense of will my thing actually work in production? Will the clients get data they expect when they query our API in different ways, and the API is in various different states. So unit tests, we can easily create them. They're super fast to create. They run really fast. We can test our implementation details however we want. But if we end up refactoring that implementation, we're more willing to just throw those tests out and rewrite them for the new implementation. And we try to not create the same edge cases and not create regressions when we do that, but definitely willing to just remove them if they start failing too much. However, with GraphQL tests, we're not willing to do that. If these start failing, it's likely client calls are going to start failing too. And if we're doing refactors, we expect these to just continue to pass. So that's the big distinction for us between unit and these GraphQL tests. If what we're doing requires us to change our GraphQL tests, then it's like, well, now we're talking to our front-end teams and other consumers and making sure that we can get those changes out smoothly. I'll just show you a quick implementation of that GQL query function. This is like mostly what it actually looks like. I just pulled it out of our code and removed some extra boring stuff. First, we build up our GraphQL pipeline. We add some absence phases we've written ourselves that just do various things, like set GraphQL operation metadata, detect whether we're under mutation, and do different things based on that. Save the GraphQL operation so we can tag metrics with it. By the way, like, you should definitely, if you're writing GraphQL APIs, you should take advantage of operations for every query your front end or like whatever makes against your API. Pass along with it a unique GraphQL operation name, and you can include that in your request metadata on the back end for like instrumentation and logging, and it's just like a really helpful debugging tool. Maybe include it as a URL parameter too for the HTTP requests that you're making. I promise you'll thank me later if you do that. Yeah, so we do that, then we just set this minimal feature context thing here. We wrote a feature flag library. It's really heavily used within and outside the API. It's exposed via GraphQL. We use it for experiments. We do ramp-ups with it, and a couple other things. And the data for that is stored in the request process dictionary, so we just set a minimal one here. And then finally, at the bottom, we execute our GraphQL query against the pipeline we created above, and kind of coerce it into a shape that's like similar to what a GraphQL resolver function would return, which is always a two-tuple OK result, or not, or error and some kind of data. And then there's this pattern that complements this really well on the next slide here. We wrap xunit.case to do a few things. One is just like import those commonly used test helpers that you use all the time, such as that GQL query function. But also a big one is we use tags to manage a lot of the lifecycle, kind of like boilerplatey things in our test suite. Things like database connections, Redis, states, feature flags, logs, metrics, and all kinds of other stuff. So yeah, between those three things, like test case, like con case, and our little GraphQL sort of query helper thing, I think we've come up with like a pretty nice developer story around just writing concise, useful tests around the client-facing edge of our system. And mostly we just were able to just step on the shoulders of the Elixir community and mostly just using things that are already built and just kind of gluing them together. And we're really happy with all that. And then, yeah, here's a quick example of an external test, the system tests. So yeah, external tests have a tag at the top there, tag external, and those are excluded from execution, like by default. So if you just run plain mixed test, they don't run. The reason for that is like these tests require an actual running instance of our server to work. This request GQL function is like sort of a similar API to the GQL query function I just showed you, except for that instead of calling absinthe run, it's actually making a real HTTP request using HTTP poison, which, yeah, it's a real request. So they run against staging whenever we deploy there. They run against prod whenever we deploy to prod. And otherwise, it looks pretty similar to the GraphQL tests. Execute a GraphQL query, make assertions about the results of that query. Pretty straightforward stuff, but they're really useful for a few reasons. One is like we just want to make sure core functionality is working whenever we deploy. The other one is we just want automated tests using like a real HTTP connection. That way we can kind of just sanity check like sort of infrastructure configuration things like are SSL certificates configured correctly, you know, these tests let like DevOps make changes to our deployment infrastructure and have a little bit of safety checks that like nothing's going to get messed up. And then the last reason, like I said before, we have a legacy system, and like while most of our app is running in Kubernetes, we definitely have a few things that are not. Like we have this old Cake PHP application that is running just on like Amazon EC2 instances and virtual machines, and they're not easy to spin up in our test environment. So this is just kind of a way we have a little band-aid to make sure that like the basic functionality is working with those. So cool. We have some tests, and they're flexible, they're pretty clean and concise, and like model our problems well for us. Hooray for us. But you could argue that even if you agree with all that, integration tests, unit tests, system tests are not enough to be confident, given all the like crazy stuff that can happen in production, like crawlers and other irresponsible API consumers. You know, you got your malicious hackers and all those sort of things. And so I'd definitely be persuaded if you were like, yeah, this isn't good enough. So how can we get from this to this? Well, we have some tricks. First of all, we have a lot more tests. Honestly, I just don't want to talk about them too much, so I'll just like touch on each one. But yeah, we like to test like every layer of the system that we can, even if tests are redundant with other types of tests. So yeah, we have end-to-end tests. We have a lot of them. They run in a real browser using Selenium. You probably are familiar with that. We use Credo for just like checking like code style and things like that. We've written a bunch of custom Credo rules to like enforce patterns automatically that like we've decided that we like. We use SoBelow. It's a static analysis tool that just does a lot of like security checks for you. Things like don't use or string.toAtom, use string.toExistingAtom. I can explain that more if anyone's interested. We use Dialyzer, help us ensure we're calling our functions with the correct types. Mostly that works pretty well. We have some property tests, and we only have like two, like, you know, of the standard like stream database property tests. We're also in like early stages of building a property style like smoke test that uses the GraphQL introspection query to help us generate random GraphQL queries with like semi-randomized GraphQL parameters. And if we end up releasing that, I guess I'll name it Aplomb. We've got load tests. Help us just shed a little bit of light on like, will this fall over when we deploy it to production? We've got this. We have compilation checks, and we just fail our builds if there's any warnings emitted during compilation. It's like, with a large team, like all of these are just helpful for various reasons. Like these are just the sort of things that like you don't want to just manually be doing in code review because like when you're deploying 20 times a day, it's like I just don't have the time, and like most people don't have the time to just check like all of these things every time. But yeah, still I'd argue that that's still not enough to like have confidence. Definitely feel like we have tools in place at this point to make sure we resolve edge cases correctly and prevent regressions. But what about all those edge cases that we don't know about yet? Property tests are like commonly an answer to this, and those are definitely helpful, but like they just don't stand in for like real production traffic. So what do? How do we catch these cases that slip through the cracks in our tests? We're in the early stages of like talking about doing things like replaying production traffic against a staging instance that I think will be really valuable, but in the meantime, we use instrumentation really heavily. Just talking about metrics and logs. Pretty straightforward stuff. We're really big on instrumentation at TBT. I'm not going to go too deep into the methodology around that, but I do want to explain it enough so you just have some context so I can talk about how we test it. And like testing our instrumentation has actually been one of our weird tricks for just adding a lot of value to our tests. So let me do a quick overview. This is a cool article. It's a short one, just kind of explaining like baseline metrics that every production system should have, and like these were touched on a little bit yesterday. Use stands for utilization, saturation, and errors, which is like typically useful for like data pipelines. But I'm going to focus on red, which is more specific to request scope data. Oops, sorry. So yeah, that's it. You want the rate of requests coming in, you want the error rate, you want the duration of each request. These are things that you should measure every request that comes into your system, so you know things happen when they happen, things that you need to react to. Things like bursts of traffic, increases in errors, slowness. Yeah. And if you have these, like these are the things that should be like at the top of your dashboard that you're looking at every day while you're doing your work. So for this talk, I'm mostly going to talk about errors. So let's talk about let it crash. It's a pretty fun and cool idea. I think you probably heard this several times if you've been writing Elixir. Basically means developers like code the happy path and process crashes. It shouldn't impact the rest of the system thanks to mutability and the process model. And thanks to supervisors, that process can be restarted, the work can be attempted again. And that's really great for lots of kinds of failures, like network failures and downstream service failures, stuff like that, but not so much for programmer errors. So like if we have a mistake, we made a mistake, or I made a mistake, which causes an error, we want to know about that so we can roll back our change and fix it. One concept I found really valuable for this, like it pays to get all the useful context you can reasonably collect up front about a request. So like you can identify the source of errors and unexpected exits quickly. It's so nice if you have the metadata you need to be able to like quickly just reproduce and debug an error without having to like start a full-on investigation, especially when stuff's on fire. You don't want to be thinking too hard. So yeah, we want to omit an error when error metric, when the request throws an exception. We have a graph. We use Datadog for this. This is a Datadog graph. We want alerts when we get a new type of error. Rate of errors reaches a certain threshold. We want an alert. So this is our graph, total uncaught exceptions. We set an alert, like we get a couple hundred of these in a certain time window. We're going to get message in Slack. We're going to get PagerDuty. Shout out to PagerDuty. And yeah, we have a service like Bugsnag or Honeybadger to help us triage new types of errors and audit them. We use Bugsnag. There's a Bugsnag library in Elixir. The maintainers are really nice people, and they've helped us get a lot of useful patches merged. So just quick shout out and thank you. So cool, yeah, we got a graph, we got an alert, and we've got a way to triage. That's nice. But in our case, we've got a lot of teams, we've got a lot of developers, we deploy rapidly, and like little old me, I'm just this guy on the platform team. I set up an alert, and the way the system works, as I described it so far, it's likely that I'm going to need to react to these a lot. I'm probably not going to be able to like sit down and focus on getting my own work done if I'm just like constantly triaging errors every time they come in. But it's not like I can just stop deploys because I don't feel like doing that anymore. So we want to get a little more advanced. So we want to assign ownership to errors. We want to give product teams the latitude to triage their own errors. Like maybe a team cares about an error that they caused, maybe they don't care about it very much. And like, that's fine, whatever, for me. They have ownership over that, and like, I can get back to like my deep work time, so everybody wins. So here's a little piece of how we accomplish this at TBT. See this def owner function. And let me just deviate for a moment so I can like brag about how great my team is for a second. We have a search team, and they're really great engineers there. We use Sphinx for our search indexing. So long story short, Sphinx's protocol is built on top of MySQL's protocol. So like we thought we could just use MariaX for this, right? No, not really. Unfortunately, MariaX doesn't yet support 100% of the MySQL protocol. Specifically, it doesn't support multi-result sets, which are like what are used in union queries, if you're familiar with those. And Sphinx uses those really heavily. So we ended up having to fork MariaX, adding support for multi-result sets. And like some of that work got merged back upstream, but not all of it because we made a breaking API change. So we maintain this fork. And that's kind of cool. Maintaining a fork's not so fun, but it was really fun to make it. We had some great hack sessions and discussions. But yeah, again, little old me, I am not so well versed in MySQL protocol. So if something goes wrong with it, it would probably take me a long time to debug. So I'd rather just have those errors forwarded to their bug snag project and like their dashboard and not have to deal with it myself. So anyway, this is the way that like we'll assign an owner to some piece of some module in our code. We just add a function like this one here. And here's a little bit of the use of our error handler plug. If you're not familiar with that, it comes with the plug library. It's a basic idea. You stick it at the top of your plug pipeline, and you can catch exceptions that are being raised within your requests and handle them. So without going into too much detail, what we're doing here is taking the error, deciding whether or not we want to report it to bug snag, and assigning a metric key to it. So like we don't really want like network failures getting into bug snag because they're just not really actionable, and like we have other ways of triaging those. And yeah, then we call this error report function, which is kind of our one-stop request error reporting function. We have a few similar ones for reporting errors that are like coming out of spawn processes as well. So let me get into those. So talking about error report, it takes some input. Error report takes in exceptions. Probably have some functions, or we do. We have functions that wrap the task module, which you're probably familiar with. If not, functions in the task modules deal with like spawning and orchestrating processes. So we definitely have plenty of requests that spawn a number of processes to do things like concurrently doing IO-bound work, things like that. And we just want to make sure we're like monitoring, reporting errors that are coming out of those correctly. And here are the outputs. Like we emit logs and metrics and maybe a bug snag report. And with these, it's important certain metadata is included, such as like, request ID, user ID if it's on behalf of a logged in user, Kubernetes pod, what feature flags are in play, and a bunch of other stuff. So basically, definitely the owner code module, or the owner of the code module is also like part of the metadata that we want to include. So to get that, typically what we do, if the owner isn't set explicitly as like a function parameter, like one of our top level functions, something like that, and a stack trace is available, we just iterate through that stack trace, skip over anything that's like not our code, we like skip over ecto and things like that. And if any of our code modules have this owner function defined that I mentioned earlier, we just call it, and that's how we get our owner. It's pretty straightforward, maybe not the best way to do it, but it works pretty well for us so far. The bug snag library has like a similar thing that it does. So that's cool. I'm just going to complicate this whole story just a little bit more. We don't always want to crash a request if we get an exception within it. Sometimes we want to gracefully handle that error. So let me show you an example of that. Yep, here's just some more stuff I just pulled out of our code and took out some of the boring parts. And this is code that gracefully handles an error. You can see the call to feature.if on there. That's where the circuit breaker lives. If you're not familiar with them, there's a really great description about them in this book called Release It by Michael Nygaard. It's a great book for dealing with some of these issues that I'm talking about today. But basically what this code does, it tries to execute this do block if that block raises an exception. In this case, it'll handle that error by just switching over to the else block and returning an empty list. Otherwise, if there's no else block, it'll just raise the exception as normal. So in this case, like what's happening is this do block's calling out to the WordPress API if we have a WordPress service. Anybody out there ever run a WordPress service at scale? Yeah, it's not always fun. Falls over from time to time, sometimes often. But we don't want the front end to like show an error page just because the blog data failed. We want to just skip rendering that while still just rendering the rest of the page, moving on with our lives. So WordPress fails, we just return an empty list and otherwise continue as normal. If the blog is failing too often, we stop calling out to it at all for a little while and just skip the do block altogether. So that's fine, but the thing that's a little bit tricky about it is like we still want to instrument those errors. We still want to know like what our error rate is, even if the request is ultimately succeeding. So I hope I've shown by now our error handling code is non-trivial. On top of that, it's absolutely critical that the error handling code works correctly. It is not fun to debug error reporting errors in production. Not fun at all. So with normal request errors, like typically our alerts are configured to go off when we hit like 100 or so failed requests in like 5-10 minute window. But for error handling failures, if there's like a single error that is the error handler doesn't handle correctly, like alerts go off. I'm gonna set up a air horn in my office for like this specific alert. Definitely gonna use nerves for that, and it'll be fun because I'll get to use nerves to get on people's nerves. So yeah, the error handling code really needs to be correct. We do a lot of different testing of our error handling code. We try to unit test each piece of it. We have a lot of integration tests. Being able to like thoroughly test the error handling code is a huge win for us in the sense of like Aplomb. So now I'll just show you some techniques we found really useful for achieving that. First one is test resolvers. Maybe you've heard of these before, maybe in just like a REST API context, but like, by the way, what are resolvers? Let me just talk about that for a second because I've been mentioning them. Quick TLDR, GraphQL, you've got fields. They represent your outward-facing schema and its types, and you got resolvers, functions that do the work of populating those fields with the requested data. It's basically fields are similar to like HTTP URLs. Resolvers are similar to controller methods. So anyway, we got a bunch of these. We have test resolvers that raise exceptions in the request process, in spawn processes, in circuit breakers, different absinthe middleware that we use for different fields. We have test resolvers that trigger database timeouts and other kinds of errors. We've got test resolvers that just sleep, and a few others. They're really, really useful for automated tests. They're also just useful for manual testing. You can test all these different error cases with the flex you want in an automated test, while we can test things like, are we handling like partial GraphQL success? So like in GraphQL, you can have partial success where some fields return data you expect and other ones error out. We just want to make sure we can handle those correctly. You can test things like, are our load balancer timeouts configured correctly? If you're not using GraphQL, you just have a REST API or like a normal Phoenix application, you can do the same thing with test controllers, and like they're easy to make and a really big win. Yeah, and this is an example. This is one of the bigger ones. It is testing our circuit breaker functionality. Basically what you see is there's this Boolean parameter called fail, and if that is true, we'll raise an exception inside of our feature block. and that way we can test our like circuit breaker functionality. Otherwise, we just return like what state the future flag is in. So yeah, they're easy to write and they provide a lot of value. You know, you can write tests that simulate behavior like pretty similar to what happens in real requests while having the flexibility to like test really thoroughly. Here's another one. It's another like really easy one. Log helpers. Our application emits logs using the standard logger and this JSON formatter that we wrote. And we emit metrics via statsd. So we whipped up a few test helpers to assist in testing that we log our fields correctly. So see this JSON log tag at the top. We'll just talk about that for a sec. Typically in our test environment, we don't use JSON logs, we just have plain console logs. It's a lot easier for developers to read. You know, when tests fail, it's annoying if all the logs are in JSON format. It's just like another step to like parsing them or just like reading them. So we just have some code in our test case module that when this tag is set, we just turn on JSON logging for this test only. Next, we got this capture JSON log function. Like if you've used XUnit much, you've probably come across capture log, and this is just a wrapper around that in addition to what that does, which is captures the logs that happen in this callback here. We just decode those logs, and what the return value is a list of maps of our JSON logs, which is just easy to make and a nice way to like declutter your tests. Like you don't want to have a lot of boilerplate in your tests. Like what you want is to be able to look at a test, know exactly what it's doing, and not have any extraneous stuff. And finally, we have this JSON log contains function at the bottom. It just returns false if no messages match a log field's value. So that works great. It lets us test our log fields without cluttering up our tests with JSON decoding boilerplate, stuff like that. It didn't require writing much code. I did this in like an hour. And you know, if I had some time, it would be nicer to make this JSON log contains function into a macro that like will like print out a diff between the value and that we expect and the actual value if there is one, like similar to how a lot of the assert macros in XUnit work. But this is still really useful. And finally, I want to talk about our statsd mock. We use statics to emit metrics using the statsd protocol. More specifically, dog-statsd protocol. It's got a few extensions on top of statsd. We decided it'd be valuable for us if we could make some assertions around these metrics. Here's an example of what a test like that looks like. At the top, we have the statsd tag, and when it's set, it spins up our mock statsd server, tells it that it wants to receive messages to our test process, and yeah. Then for this test, we just call Error.report with some statics params, and then we finally assert the call results in the statsd metric we expect, so we wait for that message. I was really happy with how this turned out, so I'm going to go a little bit deeper on it because it's sort of a fun story. So I was like thinking about a good way to test this, and I wasn't really sure how to approach it initially. I've been writing Elixir at work at this point for like about a year, and the thing is, like Beam has been around for like 25 or 30 years, and it's like pretty big surface area, pretty intimidating to like dive in and just understand it all. So I was like pretty sure I could hack together something that would work well enough, but it's like there's probably a nice way to do this, and I just wasn't sure what it was. So one of the first things I did was look at how the statics test suite was implemented. And it turns out there was a really simple solution. Definitely one of those times it's obvious once you look at it. The statics folks use the simple gen server to mock a statsd server for their tests using just like 3 callbacks. And I'll just quickly show you. Init function just opens a UDP port for listening and adds it to the gen server state. This handle info callback that receives the UDP packets, and each packet in statsd represents a single metric. and then it just forwards it along to the test process using message passing. And finally, they have a callback that sets the current test PID. So great, I thought, I can just steal this. So that's what I did. And then I wrote this little parser to parse the statsd protocol using a regex. I didn't want to clutter up the test with like parsing code after all. And here's the parsing function. It's really small, pretty straightforward. I just execute the regex on the packet. I coerce these string keys into atoms. I do a few additional checks and do a little bit more parsing, and finally just return a struct with the parse values. Here's just one of those additional checks for the metric type. I just set it from a binary to like a human readable, easy to match on atom. These are the allowed metrics types in the statsd protocol. So yeah, easy peasy, right? It took me about a day to do this, and I was able to write concise, effective tests for my error handler, which made me happy. And anybody could just easily use this to test whatever metrics that they want to test. So that's what happened. People started writing them, and for a while that was all fine. But as more tests were added, we started seeing intermittent failures. I love that slide. You probably know that, or maybe you don't, but with UDP, there's no acknowledgement that the packet was ever received. You just kind of fire it off and hope it reaches its destination, and it's never acknowledged. And typically, that's fine in prod. Like, if we drop a few metrics, like, who cares? It's not a big deal. But in a test environment, it is a big deal, and it's really annoying. So at TBT, our tests run whenever a pull request is created or modified, and whenever we merge to master before deploying, whenever we make updates to our feature flag config. Like, the test suite runs at least 100 times a day, and usually a lot more. And yeah, started eventually just getting pings pretty regularly by my coworkers saying things like, hey, just push some documentation changes. Why are my tests failing? And then I was getting too busy triaging again to get my work done, and I was getting sad. But not for long, because Elixir came to the rescue again. With UDP, delivery is not guaranteed, but with Erlang message delivery, it is guaranteed. As long as there's a process to receive them, you're good. So I just whipped up a little test environment version of our statics module to use Erlang messages instead of UDP, tweak the mock statsd server, and boom, the problem is totally solved. Hooray for Elixir. I really like it. Most of my team really likes it too. So this is just part of the story of how we ended up with valuable, well-tested error management system, added a lot of value for us. Part of the story about how I started crushing on Elixir, particularly with like this testing metrics story. Elixir just made that easy compared to a lot of non-Beam languages. Like, everything I really needed was already included in Beam, in OTP, and in the standard library. Yeah, the Elixir ecosystem just has a lot of different tools for modeling all kinds of problems, and it's really great. It's not all roses, but overall, I think we're pretty happy developers. So I just got a couple of takeaways. Elixir is a nice language. It's lovely at modeling business problems. It's concise. The process model is great for an application the size of ours because, like, in terms of like separation and resiliency, the testing story is really, really good, and like clearly a lot of thought went into it. I hope in this talk I've just shown you a few examples of like how clean and easy it is to write valuable, concise tests that give you more confidence when you go to prod. Yeah. Lots to love about Elixir. For me, it's pretty much everything I want out of a dynamic language. If you don't watch out, though, it'll bite you. So my big takeaway is think ahead. I've been maintaining a Graph API in Elixir for about 2 years, and this is what I always try to do every time I see new features and any time I see code. Thinking ahead, you have great tools like great concurrency support that let you do a lot, and they let you do it fast and clean. But just take the time to think about how your code can fail. Like, do the work up front to debug those, be able to debug those failures quickly, and prove out those failure modes with tests. It's like, cool, you wrote something that uses spawn processes to like get all your data concurrently, but like, did you think about what happens when you do that? Like, logger metadata, for example, lives in the process dictionary. Did you copy all that great metadata you set up with like your request ID and things like that when you spawned your tasks? Because you better. Like, otherwise, you're just going to see logs that are impossible to correlate with anything else that's happening in your logs. So yeah, think about instrument, test your failure modes as much as you reasonably can, y'all. That's my big takeaway. Thank you. And yeah, this is my first talk, so I should have put some references to all those images, and I'm definitely going to do that when I put these slides up.
All right, thanks, Jeff. I think we have maybe time for like one question, one or two. Any?
Developers, what surprises me is the fact that you have high frequency of delivery. Is that correct? So
Sorry, could you repeat that? I'm a little...
Yeah, so you got a small team of developers and you got high frequency delivery or deployment?
I mean, I think we have like medium large size team, I guess. Like, we have 50, 60 engineers total, like about 40 of them are writing Elixir. So I think it's like a reasonably sized team. They are broken up into like teams of 6 or so. And yeah, I think 25 deploys a day is pretty rapid, like definitely not as rapid as I've ever seen.
Well, that's pretty impressive. I have to say, I've never seen or been in a company where they do that many deployments. So, kudos.
I'm sorry, I'm a little bit...
I've just never been in a company where they do that many deployments. I guess you would need a very sophisticated testing framework or testing process.
Yeah, I mean, you need a lot of tests, definitely. We are not like a fully automated deploy. Like, it's not just like you push to a branch and then it makes a new environment, tests it out, and like merges it for you. It's like you got a few manual steps. It's about 3 steps. We have a deploy queue, so you put yourself in the deploy queue, and then when it's your turn, you just hit a button. Well, you merge to master, you hit a button, it goes out to staging, all these tests run. And then when you feel ready, you do a little manual testing, and then when you're ready, you just hit another button and it goes to prod. So we're definitely starting to brush up against people are starting to get a little frustrated, so we're like talking about like really automating the whole thing, but it's taken us a long way.
Thanks, Jeff.
Thank you. Thanks so much.